Today I'd like to look at products of sine and cosine. Now, previously we looked at powers, right? Sine cubed, cosine to the fourth multiplied. But now we want to look at these sorts of things here where you have sine of some angle times cosine of some angle and different angles. So it's not that we have different powers there, they're just different angles. And it could be sine and cosine, or cosine and cosine. The nice thing is in one step of these identities, we can get it down to something that we can integrate. Because if you look at the right-hand side of all those identities, it involves just cosine plus or minus cosine, sine plus or minus. So we can integrate that because they're no longer being multiplied. So it's pretty straightforward. So let's look at an example of how we would use these identities. Say we wanted to integrate sine 5x times sine of 3x. So let's look over here at our identities. So the first one there, sine A times sine B, is 1/2. And the first thing we can always do on these, since they all involve a half there, is just take the half outside. And so then we have cosine of A minus B, so cosine of 5x minus 3x. And then minus cosine A plus B but that just gives us cosine 2x minus cosine 8x. And both of those, I mean, they're linear u subs, but remember, with a linear u sub, you just divide by that coefficient on x. So we have our 1/2 out front. And then here, dividing by 2, 1/2 sine 2x, dividing by 8, 1/8 sine 8x. And then, of course, as always, our constant of integration. So in any of those cases, a product of sine with sine, sine with cosine, or cosine with cosine with unmatched angles or different angles, that's really the problem here, right? You can't use, you might be tempted on the sine times cosine one to use a u substitution, right? U is sine, du is cosine. But the angles don't match, right? If u is, say, sine of 3x, then du involves cosine of 3x. And if it's not the same angle, that's not going to work. So when you've got a product there and the angles don't match, 5x and 3x are different, this will get us down in one step to what we need.